Hello, hello. Actually was ready on time today. No stream key issues here. So I'm going to hang out for a minute or so before moving forward to see how many people will show up. At 10 so far, that's not too bad. Why is that what is on my stream? Hello, hello. Looks like we're not free of the technical difficulties. I need to have what's actually on my screen show up on my screen, which appears to be not what it wants to do right now. Yeah, this is not what I want to be showing on the stream. In fact, that's not even something open on my computer. I'm going to have to come back in just a second. It appears this is a little awry, so sorry about this. I'm going to boot everybody. I have to restart OBS. This looks like an issue. Bye-bye. All right. Looks like it's working now. Cool. And I can actually show what I want to show. So, sorry folks. That was another technical difficulty, but hey, we're all of 1 minute late now. Alright, so still 20 people here. Seems pretty good. And so how did the assignment go, the worksheet? Because I have that right here. Was this reasonable? Was there a point at here, like, I'm probably going to do the potato problem no matter what, but was there something else that would be worthy of consideration on here? Or a place we could start? Can you go over number 6? Okay. Yeah. I used to give this on quizzes, and this one destroyed people. Alright. So in 6 it says the integral from 0 to 6 of f of x is 12. And then it says, what is the value of the integral from 0 to 1 of f of 6x? So this is a properties of integrals question. The first step is to realize that big f of x is the integral of f of x, and if I plug in 0 and 6, it means big F of 6 minus big F of 0 is 12. And this is a really helpful starting point here, because when I go to integrate f of 6x, I'm going to get big F of 6x. And then I have to account for chain rule, do U substitution, divide by 6. And I'm plugging in 0 and 1, and it means the integral from 0 to 1 of f of 6x is f of 6, like big F of 6, over 6 minus big F of 0 over 0, or over 6. Whoops. And the key difference between this and the first part of the question we did is this over 6 thing, which didn't exist in the other one. The inputs are the same. It's still just going to be big F of 6 minus big F of 0. But we have to divide everything by 6, which means we're going to divide 12 by 6 and get 2, which is why it's d equals 2. Doink. So this is a properties of integrals mixed with U substitution / chain rule question. All right. No questions on that. Let's go to 4 and 5, which also were questions. I'll start with 4. All right. In 4, we have this differential equation. We're trying to find the equation of the tangent line at x equals 1. So we plug in 1 for x, and we plug in 3 for y, because when x is 1, y is 3. So I get 9 dy dx equals 6 over 1. Cool, that was pretty easy to plug in. Which means my slope is 2/3. Cool, done. 4 is in the books. Yeah, that one works out a lot nicer than it appears it's going to. All right, question 5 now. Okay, a particle is moving along the graph of the curve, some natural log curve. At the instant when the particle crosses the y-axis, the y-coordinate of its location is changing, so that means a dy dt of 12 units per second. Find the rate of change of the x-coordinate of the particle's location. So the key part is to realize that this is a related rates question, because they give you units per second. They tell you it's changing with respect to time by doing so. So we're going to take the derivative of y equals natural log of 4x plus 3 with respect to t. So if I do that, I get dy dt on the left. That part's pretty easy. The right part, I get u prime over u, but because I took the derivative of an x when I took the derivative of 4x, I get a 4 dx dt on top. And now we can just plug in all the pieces we know. We know dy dt is 12. Do we know anything else? Yes, we know that the point that we're talking about here is when the particle crosses the y-axis. When we cross the y-axis, it means x is 0, because that's what the y-axis is. So we know the y value at that point is the natural log of 3. Now I'm sending myself up Rats Creek or whatever here. Okay, so oh yeah, I didn't need this at all, because all I needed to know was x was 0. Okay, that's why I'm so confused. Okay, so we get 4 dx dt over 3 because x is 0. I don't know why I found y, but had we needed to find it, wow, we did. And then we multiply by 3 and divide by 4 on the left side. 36 equals 4 dx dt, and 9 equals dx dt. Chillin'. 9 units per second is our answer. How am I going speed-wise? Am I okay so far? Last time I know I went a little too fast. I tend to breeze through the pre-calc parts and leave some people in the dust don't want to do that. I'm okay. All right. At least one person thinks so. All right. Where am I going next? 9 or 1? Let's do 1. Haha. Oh, 1's a triple parter. And something I'm going to need a calculator for. Feels bad. All right. So, yeah, is this entire question something you want to do on a calculator? It appears it is. How can I do this really nicely here? Probably. X cosine x minus natural log of x plus 2. So, uh-oh. Am I smart enough to use my own piece here? Where do I get this packet? Maddie, this is on Monday. On the homework calendar, this was linked to in PDF form. Okay, so I forgot my function already. Donde? It is x cosine x minus natural log of x plus 2. So x cosine x minus natural log of x plus 2. This is a lot easier with a keyboard. All right, so now that you have this janky thing graphed, and surprise, since the AP test is online, you'll probably get to use Desmos on the AP test, so if you want to learn how to use this, this is a good time. So how many times does the particle reverse direction? All we do is look at where it goes through 0, and it goes through here and here, so that's twice. And so that answer would be twice. Did you tune into the AP live stream? They're going over stuff that they cut off the test. Oh, interesting. They're going over stuff that they cut off the test. I mean, it's just area and volume. That's what unit 8 is. I should have tuned in on it. That would have been interesting. Anyways, part 2 of this question. The object reaches its maximum speed when? Its maximum speed happens when it's farthest from the x-axis. So this one's actually a little tricky by looking at the graph, because it seems like it should be up here, but it's not, because this is much farther. This low point down here is much farther from the x-axis, which means it reaches its maximum speed here at the end of the interval at 9.538. And last one, the total distance traveled by the object is, and I'm not going to do this one in the calculator, but in order to find total distance traveled, we're going to integrate the absolute value of the velocity, which we're given in the question. And we're just going to integrate from 0 to 10, because that's our time interval. And if you integrate this, you get one of these answers. I think it's one of the 39 ones. Is the AP test just F or Q, multiple choice, or both? We don't know yet, Olivia, what the AP test is. I don't know, Nick. You said F or Q only, 45 minutes. Oh, really? For all AP tests. Okay, well, F or Qs are a big deal this year then. So good thing we're going to be practicing a bunch of those. Mr. Kennedy gave me a different graph on the TI Inspire. Daikun, if you got a different graph, you're probably in degrees. Desmos defaults to radians, so I know I'm in the clear here. You can change that up here in Desmos, but on the calculator you have to change it like by changing to degrees. This is probably what the graph you got, Daikun. This is degrees, and that's whack for this question. All right. Wow. 45 minutes only FRQ. Only FRQ is how to explain this, folks. Free response questions really, really, really benefit people who really know what they're doing. There's a pretty big divide. There are a lot of zeros, ones, and twos on the AP test for free response questions, and then a lot of like sevens through nines. Uh, so, uh, if you really know what you're doing and you're on track for a 5, you will for sure get a 5 if the entire AP test is FRQs, because people who really know what they're doing tend to overperform on FRQs and underperform on multiple choice, and vice versa. So that if it's all FRQ, like Nick says, that's what to expect. And we'll see whether or not it will actually be all FRQ when they release more information. All right, so 9 was another question I had. 9 is a straight differential equation question, separation of variables. Can you do a live stream during the AP exam? No. I do not want to get in trouble. All right. In this question, we divide both sides by y and then move the dx to the other side. So we get dy over y equals secant squared x dx. We integrate both sides, and we get natural log of y equals tangent of x plus c. We e both sides, and we get c e to the tan x equals y. And then all you have to do is use the initial condition, which is 0, 5, so c is 5. So we get y equals 5 e to the tan x. And booyah. Chillin'. Huh. I wonder if they're going to give us more information about the exam questions that will be given out. Well, like what kind of free response roughly to accept? When I typed the integral into my calculator, it said that it was undefined. It should not, unless you forgot the parentheses around the natural log of x plus 2, because that's the only part that would be undefined, Raquel. If you put the x plus 2 outside the parentheses, that is undefined from 0 to 10, but otherwise it is 100% defined. So do we have any other questions from this, or should I just go potate? Do number 2? Okay. It says find the average value of the function x root cosine x on the interval 5 to 7. So this is definitely something we're going to use a calculator for. Because to find the average value, we integrate and divide by the width. And so literally all you do is this. And chunk that into your calculator and get one of these beautiful answers. Will there be an answer key for this? Yeah, I should have posted an answer key for this. I didn't, but I should have. So yeah, I'll post one today for it. Can you do 3? Sure. Maybe I should have just done the whole thing from the get-go. All right. The number 3 says, suppose air is being pumped into a balloon at a rate given by that. If the volume of the balloon is 1.3 feet cubed at t equals 1 second, what is the volume of the balloon at t equals 5 seconds? All right, so this is a rate question. If we integrate this rate, we're going to get volume. So this is a roughly like this. I can rewrite r as dv dt because it's the rate of change of the volume with respect to time. Like so. I can separate variables. So I get dv equals natural log of t squared over t dt. And then I can integrate both sides. So this is like sneaky like a differential equation question, a separation of variables question. The left side integrates the v, no problema. And the right side, we have to do u substitution for. U equals natural log of t. Du equals 1 over t dt. And 1 over t dt is exactly our bottom and our dt. So this is a little bit of a sneaky u sub here. If I integrate this, it's just u squared du, which integrates to u cubed over 3 plus c. I can plug in what u is, which is natural log of t, and I get that my volume equation is natural log of t cubed over 3 plus c. Now I just find plus c by plugging in the initial condition. The initial condition is 1 comma 1.3. So I get 1.3 equals natural log of 1 is 0. So this is 0 over 3 plus c. So c is 1.3. And all I have to do to finish this question is take this equation and chuck a 5 in there. So I know my volume, the answer to this question, is going to be natural log of 5 cubed over 3 plus 1.3. And that's something. It's one of those answers. Leon, I swear to God that this worksheet didn't just show up there. It was there. Okay, where are we going now? I think I'm going down to what is ultimately probably the best practice for our AP tests, since it's going to be free response heavy, which would be down here. And it does not surprise me at all that they're going for free response, because they can make a bank of probably, I don't know, 1,000 free response questions to give you, and just give you 3 each of them. And then it's possible, like, everyone in my class will have all different questions on the AP test. So be prepared for that eventuality. Okay, so this question is pretty famous because when this was on the AP test, kids came to me very, very sad about this question. And so this is a really good example of a kind of veiled differential equations question. So the first part of the question says, write an equation for the line tangent to the graph at t equals 0, and use this equation to approximate the internal temperature of the potato at t equals 3. So this is entirely like Algebra 1 level math here, because all we have to do is say, hey, when time is 0, the temperature is 91. So I can find the slope by plugging in 91 for h. And 91 minus 27 is 64. 1/4 of 64 is negative 16. And so that's my slope. And then we know the y-intercept, so to make an equation, all we have to do is negative 16t plus 91 equals y. And that's our tangent line approximation. If we plug in a 3 into this equation, we get 43. And so that would be the approximate internal temperature of the potato at t equals 3. Nick, couldn't that be really unfair? Yeah, it could be. So for part B, it says find the second derivative, or use the second derivative, but we have to find it to use it, to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time equals 3. So all we have to do for this one is take a derivative of the dH dt equation, and the derivative of the left is exactly what we want. The derivative of the right is negative 1/4 dH dt. But dH dt is this thing up here. So I plug that back in, and negative 1/4 times negative 1/4 is positive 1/16 times h minus 27. Now, if I plug in temperature equals 3 into this equation here, or really if I just plug in any of the, or time, not temperature, time equals 3 or anything before 3, I know the temperature starts out pretty hot. And it tells me the internal temperature of the potato is greater than 27 for all times. So the point is this potato's hot, and then it cools down over time. And if I plug in a number or a temperature bigger than 27 in here, I always get a positive second derivative. If I get a positive second derivative, I know it's concave up. Now, if I plug in a temperature bigger than 27 into the initial rate equation, I get a negative number because it has a negative 1/4 in front. Which means I know I'm on this part of a concave up graph, the part that is decreasing but concave up. And if I take a tangent line and draw in a tangent line anywhere here, like mya, this tangent line, assuming it only touches once, is always under approximating the curve. No matter where I draw this, it is under approximating my curve. And so I know that my tangent line approximation is an under approximation. So that was all from just understanding the picture. And it's really from, the concavity is all that really matters. It didn't actually even matter that it was the decreasing part, because anywhere on a concave up, your tangent lines under approximate. They're all under your curve. All right, last part of the question. Says there's an alternate model for the internal temperature, which is this 2/3 thing. It has the same initial condition, and it says find an expression for g of t. This is a sneaky way of saying solve this differential equation, so I'm going to give myself some room here. And I'm going to separate variables. So I divide both sides by g minus 27 to the 2/3. And one thing that I always do here that a lot of you don't always do is I leave the negative on the right side, because I hate having negatives on my more complicated side. Okay, so these are separated. I certainly cannot integrate this left side using natural log because it's a power of 2/3. So I rewrote this as g minus 27 to the negative 2/3 dg equals negative dt. Now it's really easy to integrate. Right side's a joke, negative t plus c. Left side, also not bad. We just raise the power by 1 and divide by the new power. Cool. Okay, so we divided by 1/3, which is the same as multiplying by 3. So to get the left side by itself, I'm going to divide both sides by 3. I get g minus 27 to the 1/3 equals negative t over 3 plus a new c. I cube both sides. I get g minus 27 equals negative t over 3 plus c cubed. And I add 27, and I get g equals negative t over 3 plus c cubed plus 27. All right, sweet. We are missing a couple pieces here. We need to use the initial condition. When g is 0, our temperature is 91. Or sorry, when t is 0, our temperature is 91. And we get 91 equals c cubed plus 27. So I just subtract 27 from both sides. I get 64 equals c cubed, so c is 4. And lastly, all we have to do is find the internal temperature of the potato at t equals 3, which is using our completed equation, which is this guy. And then just chucking in a 3 up here. And if we chuck in a 3, we get 3 cubed plus 27 equals g, so g is 54, 27 plus 27. And in nice symmetry, we got 54 for this answer, for our calculated answer for our internal temperature. And our estimation from part A was indeed an under approximation, because if I remember right, it was 43. And so it actually makes B seem more legit when we do that. And that's that question. So that question was, it really seems, when we do it all, like a very traditional question for differential equations. But the way they asked it was not at all traditional, and took some deciphering to get there. All right. Let's see what we got question-wise. Daikun just threw a 2.7 in there. Is that a problem in this packet? Actually, don't think so. So I can't read into that too much. Are there any other questions on this before we ditch this document? Oh, that is an answer. Oh, okay. So, Daikun, you were just telling us the answer to this one was 2.7. This one I did up here or wherever. That one. The balloon question. Gracias, senor. Oh, you want to do the matching question, Raquel? So, the matching question's kind of fun. One of the easy way to think about some of these is to just think about the parent, like if you integrated it. If you integrate x, you get x squared over 2, so it's just the parabola. If you integrate x plus 1, you get x squared over 2 plus x, which means this thing shifted left. And so that's, what is that, FG? And so we can get a couple of those for like super free from the get-go. Each day could we do kind of do for FRQs focusing on one unit? Yeah, definitely. All right. And then I'll do the last question after this. This requires thinking though, which is really hard for me right now. Okay. Y prime equals y means the slope of the graph is just equal to the y value. And so that's like this guy here, which has its slope always equal to its y value. Or, yeah, no, it's just that guy. Q. Wait, y prime equals 2y. Oh, crud. Did I mess this up? Yeah. This one's F, this one's C. Because both of those just get bigger as their y values change and have zero slopes when y is 0. And so we have a y over 2 here, which is the one that follows these exact same, like looks exactly like these, but is less steep down here. And that's that guy. Message retracted. Interesting. I didn't know you could do that. All right, and then this one, y prime equals 1 over x, should look like a natural log graph. So it should look like A, because A is a natural log graph. What is this one? This one's just an absolute value graph. So that would be like a B. And then I only have 2 remaining. We're almost free of the curse of having to figure these out on the fly. Okay. 1 and 1. This should be y prime equals x plus y. So this is when x is y 1 and y is negative 1. These should cancel. It should look something like this, but this doesn't work for, so I'm a little confused. That one just might be a little whack. Oh, we got double message retracted? Oh, Liam's just trolling me. I got you. So x over y. Oh yeah, this one's definitely I. Which means this one has to be D, but that one seems a little questionable. I think the values are a little whack there because 1 plus 1 is not 0. So these 0 slopes should be going the other direction. So if you got confused by that and wished it looked like that, I think it's because it should look like that. Oh, Liam wrote, I hate you. Okay, we're going to hide that one. This is confusing. Oh, sorry. 7 out of 9, yay me. All right, different reactions. So yeah, Raquel, ultimately, one of the good plays here is to like look at 1, 1, plug it in, and see if you get the slope that you should expect from the equations. What I'm doing for a lot of these is just solving the differential equation kind of in my head. You can do that also, but there's a lot of different routes to all of these. These 3 were all basically the same. It was just the steepness that determined them. These 2 were both parabolas. And then I actually had to think on the other ones because there was more going on. This one was a natural log graph because it was a 1 over x, and that sort of thing. So I apologize for being a little confusing there. It's just these actually bend my mind more than any of the algebra ones do. All right. Let's dump down to the last question, which I got a quick question about. And it's very FRQ-y. All right. It says a different population is modeled by a function y that satisfies the separable... Yeah, this is our differential equation. Cool. Find y of t if y of 0 is 3. That is, C just asks, solve the differential equation. Separate variables. If we separate variables, we divide both sides by dy. We get dy over y. We multiply the dt to the other side, and we get 1/5 times 1 minus t over 12 dt. Okay, so now the play is integrate both sides. dy over y, easy. Natural log y. This garbage over here, I'm going to get 1/5, because that's the coefficient, times the derivative of the inside, which is negative 1/12. Wait, derivative, integral. Sad panda. Integral of the inside. Yeah, I don't want to do that garbage, so I'm not going to integrate this right away. I'm going to distribute the 1/5 to both of those, and then integrate so I don't have to do some horrible chain rule garbage. So I just distributed the 1/5. Now I'm going to integrate and get 1/5 t minus t squared over 120 plus c. I'm going to e both sides, and I'm going to get y equals c e to the 1/5 t minus t squared over 120. And then I'm going to use the initial condition, which is a super gravy initial condition, which just tells me c is 3. Because if I plug in 0 for t, it's e to the 0. So when they give you zeros, it's usually way easier. Y equals 3 e to the 1/5 t minus t squared over 120. And then it says, for the function y found in part C, what is the limit as x approaches infinity of this equation? So if I approach infinity, this is smaller than t squared over 120. So that means this is e to the negative infinity. E to the negative infinity is 0. So this is 0 as you approach negative infinity. And that's it. So that question was just a separation of variables question. I would argue that this one was actually pretty hard to separate variables on, or see the separation on, because they are so kind of directly adjacent to each other, and pulling them apart requires you to see that you can just divide by y here. So that was a little bit tricky, for sure. All right. How are we feeling, folks? Are we mathed out? Should I talk about what I'm asking you to do for tonight, today, tomorrow? Because generally the thing that I am assigning, not generally, just actually, is we're going back to AP Classroom here. One person has logged in. Who is this person? Oh, I don't know. Too lazy to check. And it's called Unit 7 Progress Check. So if you look at this assignment, I can see no one started. Wow, what were they thinking? Where is that? You can see my view here is actually pretty garbage. Can I see the actual assignment here? Anyways, if you click on these things, it's something like 17, 18 questions. It's a review from this unit, so it should be really similar to that worksheet, but more multiple choicey this time around. I'm going to be focusing more on assigning free responses coming after this. This was just the second part of our wrap-up of differential equations, and honestly, differential equations are ultra likely to show up on the AP tests. Are we going to learn anything new from now on? No, before the AP tests. Yes, after the AP test is the answer, because even though we're not going to cover areas and volumes before the AP test, because it's not going to be on the AP tests, I'm going to cover them for sure, because if you get a 5 on the AP test and you test at a Calc 2, you're going to really want to know how to do areas and volumes. And so I'm definitely teaching those afterwards. Like, there's a reasonable chance we don't go back to school this year. And so my live streams will switch to doing that after the AP tests. So I'm definitely going to cover it. So it's all review from here on out. Yes. Kruzich took a whole day to assign 3 FRQ questions on AP Classroom. Okay, cool. Seems good. I will definitely be assigning questions on things. Should we do that Unit 7 progress track? Absolutely, yes. The only reason I was deliberating about it is because I can't actually click on it and show you what it looks like, because it just gives me this janked out view that's completely useless here, where I can't even click on anything, which is a little annoying. But yes, please do this thing. And that is what I would like you to do before next time. Is our test still on May 5th then? Yes. So you say we won't go back to school this year? I think it's unlikely that we will go back to school this year. Are these graded? No, I can't grade anything. It's illegal for me to grade anything. However, AP Classroom will tell you whether or not you did it right. So that's kind of cool. Is the only work you want us to do the ones on AP Classroom? Absolutely, yes. No school the governor is a Democrat. What? What does that even mean? Some of my other teachers are grading and breaking the rules. Yeah, interesting choice on their part. That's a great way to get sued. I would absolutely not recommend doing that. However, Maddie, teachers are allowed to grade stuff as long as the stuff was assigned before we left for break. So that's why I can't grade anything else because I didn't assign anything else. So, uh, yeah, that's how that works out in our case. Uh, yeah. Um, Trying to think of what else I should say. I'm planning on doing just a random question and answers live stream on Friday where you can come and ask me any questions. So it's less like I have a formula for the day, and you can just show up and ask me to do random questions or anything. Ask me to review something from like chapter 3 or some things like that. Like I want that to be a little more like tutoring based for. Okay, so basically the reason why I want to do stuff like this is my wife tutors, and she is mostly just tutoring for people who can't afford it because she, gets paid to do it. And I want everyone to have access to tutoring even if they can't pay for it. And so I will be doing that on Friday. Can you have a warm up on the live streams? Nick, I was actually thinking about that. I probably should start doing that. I wonder, it kind of gives me a chance to like go eat some food or something, because like I could just post a warm up for the first 15 minutes, just leave it up there and have people work on it. I kind of like that idea because it works even if there's a video, because it can give people a chance to like work on it. And honestly, based on what you told me about the AP tests, our warm ups are basically always going to be free response questions. So I like that. I think that's a really, really good idea. And I will start that like Monday or Wednesday. I like that. Or you can just talk about life when we were working, or I could play video games. That'd be pretty dope. Because like that's what my life is right now. It's like play video games, do work, or like work out, play video games, eat food, play video games, go to sleep. Wow. Give us some video game. Play Doom. No, I don't really like playing Doom. I don't like shooters. Sorry, guys. So yeah, I'll prepare a warm up for Monday. Fridays. Well, okay, for Friday for that live stream, I think I will do a warm up at the beginning and make it pretty review based, because people who show up for that sort of thing maybe would benefit from that sort of thing. So, I'm planning on Friday, doing 1 p.m. So Friday, 1 p.m. I'm doing first 15 is a warm up, then random tutoring, and I'm not assigning assignments on these Friday sessions, only on Mondays and Wednesdays. And I'm way too lazy to figure out how to play music on this thing. That would require extra work. Are you still doing your New Year's resolution? God, no. Oh, man. I'm just happy my foot's finally better. Because I can actually like do elliptical for like half an hour now. Which is awesome. You could do that extra work. It's worth it. All right. Well, hey, it was great talking / seeing you all. Should we be doing multiple choice practice or no? You absolutely should. It's not like the concepts are different between FRQ and free response, but if you had to focus on one thing, you should focus on free response. So I'm going to start transitioning to doing more free response, but multiple choice is absolutely not worthless. Like the skills are very similar. Like really the only difference between multiple choice and free response is free response requires you to like read and discern a little bit more to do, whereas multiple choice is a little bit more like exactly which skill you're going to use every time. And that's kind of the big deal. So yeah, starting next week, we're probably going to be slamming something like 3 or 4 free response a day or something like that, and that'll be good. I know the AP test said it will not include multiple choice questions, but folks, multiple choice and free response are really similar, like really, really similar. Yeah, it does not hurt to do them. Multiple choice will refine your abilities in the very similar way to free response. All right. To not beat a dead horse too much, try this multiple choice check online. Test your might at doing differential equations questions. And I'll see you Friday or Monday, depending on when I see you next. And I hope you have a wonderful week, even though things are a little dark right now. All right.